Alright, this screencast is for D period for Friday, October 30th. We're going to go through most of the lesson in this screencast. I'm going to save the two hardest examples for class on Tuesday or Monday, whenever I have you next. And then we're going to do a little bit of review next class. And so, most of these it's pretty straightforward. The idea with sum and difference identities is if I would ask you something like, what is sine of 30 degrees? You could spit out the answer. We know this. This is a special angle. We're fine. But the issue comes, what if I ask you an angle you don't know, like sine of 15 degrees? That's not a 30, 60, 90. That's also not a 45, 45, 90. All right, or any of the multiples on the unit circle. So remember, all of our angles who have a reference angle, that is a special from our triangles, and we don't know 15 degrees. So how would we even approach this? Well, we have something that's called the sum and difference identities. I don't know what I'm erasing this. I don't know why. Okay. Sum and difference identities. So what we can do is, instead of saying, sine of 15 degrees, I can write it as a sum or a difference of two angles. Our choices we can use are the ones that we know. So we can use 30, 45, 60, 90, or multiples of these angles. So, we could have, 1660, 120, 180, 240, 300. Those are all the multiples of 60. All the ones that are reference angles in our unit circle. Okay. And so if I want 15, well, I could do 60 minus 45. I could do 45 minus 30 degrees. And then this gives me a difference. I'm literally subtracting one angle from another. So your first angle is alpha, and the second angle is beta. All this means is we just have to distinguish between two angles. If you have twin children, you're not going to name them both Bob. You need some way to tell the difference between them. So that's why wherever you see an alpha here, okay, we'll plug in 45 degrees. Whenever you see a beta, we plug in 30, and then this makes it a lot easier. We know what sine of 45 is. Cosine 30, cosine 45, sine 30, and then you just plug in the values and simplify. That's the idea. The hard part is understanding, okay, so what angles do I use? That's hard. All right, so find the exact value of the trig expression. I have sine of 75 degrees. So I'm going to write this as, sine of 30 plus 45. Alright, so this is the one I'm going to use. Everywhere there was an alpha, I put in a 30 degrees. Everywhere there's a beta, putting in 45. Right, just plugging in. Once I found which angles we'll add, I just plug and chug. So sine of 30 plus 45 is going to be sine of 30 degrees, cosine 45 degrees, plus cosine 30, sine 45. Alright, let's take the easiest ones first. We know cosine 45 is just root 2 over 2. Sine of 45 is just root 2 over 2. And then I'm taking sine and cosine of a 30 degree angle. If you don't remember, I can just draw it out. Okay, so sine of 30 is what's opposite, so this is 1/2, and cosine is what is adjacent, so that's root 3 over 2. All right, let's go ahead and simplify this out. So this first term, I'm multiplying these together, remember? So I have root 2 over 4 plus, second term, difficult. So when I have two radicals being multiplied, root 3 times root 2, it's the same thing as multiplying what's underneath them. So I can say root 6. 3 times 2 is 6. So root 6 over 4. And then, they have the same denominator. So I can write my answer as root 2 plus root 6 all over 4. And keep in mind it said the exact value. Exact values always have things in terms of a radical or pi, aka no decimals. So I'd like you guys to stop the video, try part B, and then continue on when you're ready. So I'm just going to keep going. All right, so first step, I don't know what 11 pi over 12 is. This sucks. But I can break it up either into a addition or a difference, right? So first, if I convert this into degrees, maybe that will help us. Let's see, 2, 30, 15, let's see. I think I did that right, divided by 6, 32. All right, 15 times 11, 150, 165 degrees. Okay, so let's see. We know that this would be 180, so I'm in the second quadrant for sure. 165, let's see. The only angle I know with a 5 is 45. So if I subtract 45 degrees, I get 120. Oh, okay, this is fine. So I'm going to use 120 degrees and 45. Yeah, because that's 160. 120 is just a multiple of 60 degrees. So if I convert back into radians, I have pi over 4 and 2 pi over 3. Because this portion would be the 2 pi over 3. This portion is the 45. Okay. Let's see. Oh, and I want to add them. Okay, so I'm going to rewrite this as tangent of 2 pi over 3 plus pi over 4. Together, those should equal 11 pi over 12. You could do the addition if you want. Let's see. This is the one I'm going to use. So once I know the addition, once I know the sum, I just plug in. Okay. So I have tan of 2 pi over 3 plus tan of pi over 4 all over 1 minus tan 2 pi over 3 tan pi over 4. Okay. Alright, so I'm going to draw my two triangles. So when I have a 45, 45, 90 triangle, tangents opposite over adjacent while our two sides are the same. So that's just going to be 1. So I'm going to rewrite those equaling 1. And of course you could plug in all at once, but that would make it a little easier if I simplified. Alright, now I'm looking at my 30, 60, 90 triangle. 2 pi over 3 is 60 degrees. 2 pi over 3 is my 60 degree angle, 60 degree reference angle in the second quadrant. So I look at 60 degrees, I want opposite over adjacent. Where can I put this? Opposite, root 3 over 2, over adjacent, 1/2. This cancels out, we're left with root 3, but we're in the second quadrant, so it's negative. Alright, second quadrant, so we're negative. Alright, plug that in. I'm going to come down here. So I have negative root 3 plus 1 over 1 minus negative root 3, so that's 1 plus root 3. Because I'm subtracting a negative. I have a negative here, I have a negative here, so negative, negative turns into a positive. Okay, well, this would be okay, except we have to rationalize our denominator. Right, this isn't just root 3 on the bottom, this is 1 plus root 3, so we have to multiply by the conjugate. Multiply the top and bottom by the conjugate. Okay. Write it out. So we're just FOILing the top. So I have negative root 3 first, outer, plus root 3 squared, inner, plus 1, last, minus root 3, over, let's see, 1, minus root 3, plus root 3, minus root 3 squared. Okay, those cancel. That cancels. That cancels. So we have negative 2 root 3 plus 4 over 1 minus 3 is negative 2. So a large part of this problem is just algebra, right? once we split the angle, all right, once we knew the addition of the angle, all right, which two to use to add together, plugged into the formula, and then it was just like using chapter 4 knowledge of knowing what the angle measurements, like the trig of the angle measurements are. And now like this whole portion right here is just algebra 1, rationalizing. All right, simplify this out. So I have root 3 minus 2, and then that's the whole answer. This is much better than the nasty gram we had earlier. All right, alternating current in amps of a certain circuit can be found in t seconds. All right, rewrite it using the sum of two measures. So it's going to be I equals 4 sine of two angles being added times t. So 255, let's see. The only thing, right, when we end with a 5, we have to have something with a 45 degree. And then this is going to be 210. So I'm like, is 210 a multiple of my angles? Like multiple of my special angles? Let's see. 210 is here. And if I'll go halfway around, it's 180. Oh, okay, so this is going to be a reference angle of 30 degrees right here. Reference angle of 30. Okay, we can do this. Use a sum identity to find the exact current after 1 second. Okay, so come up here, sine alpha plus beta, sine, cosine, cosine, sine. Okay, so this is going to be 4 times sine, cosine, cosine, sine. Let me make sure that's what matches, because this is my alpha, this is my beta. So sine alpha, cosine beta, plus cosine alpha, sine beta. Okay, cool. So we're good. You guys will have the identity sheet when you guys take the test and quiz. It's test now, sorry. You will have the identity sheet when you take it, so don't have to worry about that. You just have to know how to plug in properly and figuring out the right angles. Okay, easiest ones first. These are root 2 over 2. Oh, and we want after 1 second. So that means time is 1 second. Just plugging in for what I know. All right, 210. Let's knock this out. So my angle is over here, 210. So I'm looking at a 30 degree angle. But I'm in the third quadrant. So both of these are negative. Instead of doing the positive and then saying, oh, students take calculus. Nah, I'm just going to have the things be negative from the start so I just can plug in. Okay, sine is the y value. Cosine is the x. And keep in mind, like the way I drew my triangle matches here, right? This is a reference angle of 30 degrees. And so that's why I drew my 30 degree angle right there. Okay, simplify this out. So we have 4 times, I'll do this first, negative root 2 over 4 plus, just kidding, it's minus because we have a negative. So minus root 6 over 4 times 1, leave that 1 out. Anything times 1 is itself. Distribute the 4 out, the 4 cancels everywhere, so it's negative root 2 minus root 6. Okay. Sometimes, so what we've been doing is we've been taking like sine of an angle we don't know and rewriting it in terms of an addition or subtraction of two angles we do know. Now this is expanding. That's not always easiest to expand. Sometimes the better thing to do would be condense it. So notice that I think of it as going like backwards. Instead of making a small thing be this long formula, we can take the long formula and make it into a small thing. So notice that we don't know tangent of 78. We don't know tangent of 18. But this is, let's see, if I have tan minus a tan, right here. Tan of alpha minus tan of beta. Let me zoom out so I can see. Tan of alpha minus tan of beta. 1 plus tan alpha, tan beta. Okay, cool. So this is just going to be tangent of my first angle, 78 degrees, minus the second, 18. Okay, cool. Simplify that out. We know this is going to be equivalent to tangent of 60 degrees. All right, draw a 30, 60, 90 triangle. If you don't already remember, you can always do the shortcut. Tangent is opposite over adjacent, opposite root 3 over 2 over 1/2. So this is just going to be root 3. A good way to remember this is when you have root 3 versus root 3 over 3, the larger number goes with the larger angle. So, alright, I want to do the same thing here. Like, we know what pi over 3 and pi over 4 are. I just would like to condense it down, simplify it. That's all. I would like to know, what is this an expansion of? So this is alpha, beta, beta, alpha. Okay, and it goes sine, cosine, cosine, sine. Okay, so I'm looking sine, cosine, cosine. Oh, okay, these are cosine, cosine. Nope. It's got to be sine, cosine, cosine, sine. Okay, it looks like this guy. And I'm adding in the middle. Let's see. Yep. Because when I have the alternating, it's either going to be sine of alpha plus beta or sine of alpha minus beta. So that was my big question. It's a plus because this is a plus and matches. So I can write this as sine of pi over 3 plus pi over 4. And now this is an algebra problem. Make a common denominator. And so it's sine of 7 pi over 12. So as I said before, I'm skipping 2 problems because they're harder, and then I'll walk through them with you next class. And I'm skipping that one. So we still have 2 problems left. Not too bad. All right, verify cosine of negative theta equals cosine theta. Okay, remember, we want to have one side simplified so it equals the other. So immediately you'll be like, wait, this is just the even-odd identity. Yes, what we're doing right now is we're proving the even-odd identity. Surprise, it's back to, geometry. Proving even-odd identity. So, if only I could use a sum or a difference. Oh, I can. So I can say 0 minus theta, and now I have a difference identity, because it's 0 minus theta, that's just negative theta. I might go up to up here. Okay, I'm subtracting cosine, cosine, sine, sine, and notice that this is a minus, but this is a plus. Cosine, cosine, sine, sine, cosine, cosine, sine, sine. Okay. Cosine, cosine, sine, sine. Alright, we know what cosine of 0 is. It's 1. Cosine of sine is 0. So we have cosine of theta plus 0, because anything times 0 is itself. So this turns out just to be cosine of theta. Cool, so we proved the even-odd identity. Using our sum and difference identities here, we're proving the even-odd identity, whatever. This is proving the cofunction identity. Okay, so we want it to equal sine at the end. Once again, this is cosine's difference identity, so it's going to be cosine of alpha times cosine of beta plus sine of theta, sine of theta, which is my alpha, and then sine of beta, which is pi over 2. So this negative here only tells you which formula to plug in into the cosine difference identity. Okay, we know that cosine of pi over 2 is 0, sine of pi over 2 is 1. Rewrite this as 0 plus sine of theta, so this is just going to be sine of theta. So that's it for this screencast. We're going to go over the next 2 problems, and then we can go over any questions you had. Cool.